Okay, can you hear me? Yeah? Okay. So, as we like to say in a hacker context, Emacs is often seen as an operating system, right? So this talk is going to be about an operating system, well, a distro, which tries to be like Emacs. So that's kind of the other way around. So what does it mean, actually, to be like Emacs? What's the nice thing about Emacs? Well, Emacs means Emacs makes all computing simple, right? Not everyone agrees. Some people have found other meanings to the acronym, but yeah, I tend to prefer the first one. So what does it mean concretely? If we take back those 4 freedoms of free software, how does the design of Emacs relate to those 4 freedoms? So of course we have licenses to guarantee those 4 freedoms, and the GNU GPL typically makes sure you cannot remove those freedoms, which is a nice thing. So that's the legal part of free software. But now, what does Emacs do to help with that? Well, what we can do from a technical viewpoint is to make the first freedom more practical. Okay? So the idea for Emacs is basically you take freedom number 1 and you map it to a concrete system design. So that's what we're trying to do with Guix package manager. So actually, if we look at early writings by Richard Stallman about the design of Emacs, he was saying basically that with a programmable editor, people would end up programming without really noticing. And so this helps improve computer literacy. That's kind of fashionable word these days, but this is a writing from 1981, right? And the idea was that, secretaries perhaps at the time would use Emacs, and so these are typically people who were taught by society that they would be unable to program. But with a programmable editor, the hope was that, with Emacs, those people would finally end up being able to program by themselves. So they would really be in control of the software they use, right? And yeah, that's the hope. Of course, nowadays, if you look at what people are using, like if you look at what secretaries are using, they're using probably free software, sometimes proprietary software. But even free software like LibreOffice is not something which will help you gain the ability to program. It's free software from a legal standpoint, but it's not software that will free its users in a way that they can, manage to extend it and to hack it and learn how to program. So I think we have the same sort of situation with distributions. So, yeah. So of course, if you look at, so Emacs predates the GNU project. But if you look at the GNU project and the 4 freedoms and all that, it's really the same spirit. It's trying to help emancipate computer users, trying to put people in control and allow them to actually control the software. And again, that's what we're trying to do with the GNU Guix project. So concretely, what are the barriers to distribution hacking? Well, if we consider Emacs, what it allows you to do is to easily study how it works and to easily extend it. And that's something that's not really possible with many distributions and package managers nowadays. So of course, the first thing we would like to do technically is to allow packaging to be more, not an expert thing. We would like users to be able to do packaging. And we would like users to be able to extend the distribution. So just as an example, I happen to work in a research institute with many people doing high-performance computing. So they have a shared cluster. And some people, each research team wants to have their own piece of software. So they want to have, let's say, some scientific software compiled with a very specific MPI version. And another team will want to also have the same software package, but compiled with a different MPI implementation so that they can compare and that kind of stuff. And on top of that, each user within each team wants to be able to choose when they upgrade. So a very common problem on clusters is, you have sysadmins taking care of install packages, and researchers doing their stuff, experiments and benchmarks. And suddenly, sysadmins decide to upgrade all the packages. And so your experiments no longer work as you expected them to, because you just suddenly change all the underlying software. So that's a very common problem. And yeah, in addition, people on clusters typically use environment modules to handle that, which amounts to basically making a new distributions by hand on the machine. So I think Distros should be able to help more on these kind of topics. And this is related to what Luca was explaining before. Distros should be able to help people in these use cases. Package management tools themselves are also kind of arcane. It's really hard to get in and to hack them, to modify how they work very often. And yeah, of course, when you install an operating system, you have all sorts of esoteric configuration files, formats, everything, which makes it, again, a bit harder for someone to come in and say, look, I'm going to change how things are configured. And lastly, if you look at a typical GNU Linux system, or Unix system in general, we have all sorts of programming language barriers. I mean, if you look at a typical system, you have a whole set of bash scripts to, for instance, initialize the system. Or you have a big C daemon which takes care of system initialization and stuff. You also have, all sorts of Perl, Python scripts all around. All this makes it quite hard to hack the system, to understand what's going on. Because each time you want to look at something, if there's a language barrier, you're probably, at least that's what happened to me in the past, probably you're going to say, okay, I just stop here, stop at this level, and I see later for the next language, right? So I think all these are typical barriers to distribution hacking. And this is where GNU Guix comes in, right? Yeah, so it's like Emacs. It's not a solved problem yet, but I think we are able to solve a bunch of problems, notably some that Lucas mentioned just before. So I guess it's time for a demo, because all this hacking stuff is cool, but at the same time, we want to be able to actually do something with the package manager, right? So. Okay, so we basically, with Guix, we provide a single command, which is called Guix, with a number of subcommands, nothing very unusual. So let's say I want to install a package. So obviously, the first thing I would want to do is to install Guile. So Guile is a scheme interpreter, compiler. So I just type Guix package-i Guile. And I don't need to be root to actually do that. And yeah, it's telling me, OK, Guile is installed now. Or it's complaining because I don't have network access, which is fine because I already have a local copy of the binaries. If I do which Guile, well, I can see it's around here. It's actually in a .gix profile directory in my home directory. So this is fine. Now, let's say I want to install a different version of Guile. And yeah, Python. So what we're doing here is that we're doing a single transaction. And in a single transaction, we're installing two packages. So if you went to the talk by Nicolas Pierron this morning, you'll probably recognize a few bits about Nix and NixOS. And you may be able to spot differences as well, because the whole set of packaging tools is different. OK, so what do we have now? Well, we have actually downgraded. It's saying upgraded. OK, we found the bug. We've downgraded Guile, and we've installed Python at the same time. And the tool is telling us you should be careful about search path. So I don't know about you, but I think search paths are one of the most difficult problems in computer science. I mean, we always end up having problems just because we forgot to set the environment foobar paths correctly. And so here the tool is helping us. It's telling, be careful, you don't have a Python path variable, so probably it's not going to work as expected. So you can just, export that variable. And yes, now I have the old guide version installed. What else can I do? Yeah, let's say I want to install guide.json, which is a JSON interface for guide. Okay, again, it's telling me I have yet another environment variable that I should define for things to work correctly. Well, so far, so good. So let's say I'm unhappy with my current configuration. I can always roll back. Right? And now if I list the installed packages, obviously I'm back to the situation where I have just guide 1.8 and Python. Okay. Okay, but of course, if we want to be the Emacs of distros, we need an Emacs mode to begin with. So fortunately, a fabulous Guix hacker called Alex Cost came up with an Emacs mode which allows you to do all that from within Emacs. So let me just show you. So first, I can list all the packages which are installed in my profile. So this is my real profile. The other one was for the demo, right? So I have a whole bunch of packages installed. And let's say I want to install a new one. Yeah, I can list the latest versions of the available packages in the distro. And what could I install? Yeah. Let's say I want to install NVI. So I can just type enter on it, and I have the description and stuff about NVI. And if I go to the install button, so it just gets installed pretty much like what you get with the Guix package command, except it's in Emacs. Yes, now it's installed. And I also have direct access to the source code, so I can, like if I hit show, yeah, I can directly see the source code of VI, which is nice from a free software perspective because you have a direct connection to the source. Luca was mentioning that Debian is providing meals, and actually Guix is providing meals and recipes, in the sense that you have both the recipe for the package and you can get the binary as well. So the recipe itself is just here. So if I hit enter, I see the recipe in the distribution, which is this expression. I get back to that later. And so I can directly hack it if I want to change it. Yeah. So another thing I can do with this Emacs mode is to list the generations of my profile. So a generation is just each time you make a transaction, like you install packages, you remove packages, you just create a new generation. And from within Emacs, I can select 2 generations like this, and I can ask for a diff between the generations. So what it's telling me here is that, well, the difference between the 2 last generations is that I have a new package that appeared. I mean, it's a diff, right? Yeah, and this is it. So I can do that sort of thing for any generation. So this is quite useful because if you find out that something broke in your set of installed packages, you can always check what happened, right? And see what the differences are. Okay, let me go back to the presentation. So what's the workflow like? So basically you have Guix developers, typically, or Guix users, writing those package definitions. And when they are done, I mean, they test the definition locally. So you can always write a package definition. You run Guix build name of your package, and you make sure it actually works. And then if you have commit access, you just push it to the Guix repository. And finally, users, they can just pull recipes from upstream from Guix. And from there, they can install the new package. That's a very straightforward workflow. And in addition, we also have a build farm, which is basically doing continuous integration of the distribution. So from there, you can fetch binaries if you want to. And I mean, the tool will automatically use binaries if they're available. And if they're not available, it will build things locally. So that's kind of a different workflow from Debian, for instance. Luca mentioned before one of the dirtiest secrets of Debian, right? Which is that actually Debian maintainers, Debian developers upload software which they built on their own machine. And so, you know, what kind of trust can you have in that? I'm just paraphrasing what he said. So here we have that build farm making builds. But since every user also has recipes locally, you know, every user is able to build software by themselves. And so you can, if you don't trust this build farm, you just don't use it, right? Yeah, you just don't use it. You can configure Guix to not use it, and you're fine. Well, you end up building a lot of software locally, which is not always convenient. But you can also run your own separate build farm, and then you can check if you actually get the same results compared to the official build farm, right? So yeah, there's no maintainer uploads, no single point of trust, which is pretty nice. So reproducible builds is a hot topic these days, thanks to our friends at the NSA, GCHQ and stuff. We realize that it's important to be able to have more guarantees on the binaries that we're using. So in Guix, which is similar to what happens with Nix, when you build software, you get one of these long file names with a hash. And the hash actually denotes a hash of all the dependencies used to build the software. So for instance, when you build Guile, you need a compiler, you need a C library, lots of other libraries. And this hash that we see here is the hash of all these dependencies. So you can query the references. And what happens is normally, if you take any two users building Guile from the same Guix recipes, well, they get nearly binary identical binaries, right? So I say nearly because there are always sources of non-determinism in package build systems and stuff like that. So fortunately, the reproducible.debian.net project is working on it. And it's mostly a cross-distro issue, actually. Oftentimes, the problem is upstream in build systems and stuff. And so what reproducible.debian.net is doing is beneficial for all the free software community, which is really, really nice. And I think there's a talk about reproducible.debian.net at 4 p.m., if I remember correctly, today. So yeah, and so, yeah, as I said, with the NSA and other spy agencies doing all this kind of crazy stuff, it's really important to be able to improve what we have here in the free software community in a broad sense. Okay, so I said we were supposed to talk about hacking, so let me show a little bit how a user can hack Guix. So what do we have? Okay, let's take, for instance, the definition, the recipe for the Emacs package. So it looks like this. It's actually scheme code, but you don't really need to be a scheme hacker to understand what's going on here, right? It's purely declarative. So we're saying, you know, we're giving the name version, we're giving the URL of the source code, a bunch of metadata, the kind of build system which is being used. Yeah, here we're fixing a bunch of stuff in the source files. And then we're describing dependencies, blah, blah, blah. You know, so it's the usual thing. And yes, this is from Emacs. And since this is scheme code, regular scheme code for Guile, we can actually use Geyser. So Geyser is an Emacs mode, which allows Emacs to talk to Guile, right? So what we have here is we have Emacs and we have a Guile process, and they are talking together. And so when I put the cursor on a variable name, I'm not sure if you can see it in the bottom line, but Emacs knows what this is, right? It's a variable defined in such module, blah, blah, blah. And so we can use method dot to just jump to the definition of the library. It didn't work for this one. Yeah. So if I can jump to the definition of libxml2, for instance, and yeah, likewise, I mean, and so forth. So that makes it very easy to navigate through the distribution. You know, you just type method dot like when you're using tags and stuff, and yeah, that's it. Okay, so let's say I want to customize Emacs because I'm not satisfied with the default package. So what can I do? Well, I can define another object, which is this one, for instance, Emacs no X toolkit. So again, it's a regular scheme object that we're defining, a regular scheme variable. And here we're just saying, okay, I take the inputs of the original Emacs, but I remove GTK plus. All right? So what I get with that is I have an Emacs package, but without GTK plus as a dependency. So I get an Emacs package which can be used on X11, but without GTK plus. And yeah, with this inherit keyword, which means I'm just copying the original Emacs recipe, and I'm just modifying a couple of things. And of course, in pure Lisp spirit, I can go to a REPL. So basically a read eval print loop. And from there, I can say I want to import the Emacs module. OK. And if I type Emacs, well, it's a normal variable. So I'm just giving a representation of that variable's value. Is Emacs a package? Yes, it is. I can query the values of all its fields. Like I can get its synopsis and stuff. And so we have a complete API to manipulate packages. So it's actually quite useful. So let me show you something. Yeah, so we have another fabulous hacker, David Thompson, who developed GixWeb. So it's a prototype currently, but it's a web interface which allows you to to view packages and to install them in your profile and stuff like that. So let's see if it's still working. Yes. So let's assume, yeah. So you can search for packages, and so the browser here is just talking to Guile's built-in web server. So we have a Guile program which runs Guile's web server, and that Guile program also uses Guix as a library, because Guix, the package management tool itself, plus the distribution, all this is just a big library. Okay. So we have that web server which is just using all this and browsing the list of packages and stuff. So yeah. Can do a bunch of stuff, editor. Yeah. So you can click on install, and yeah, it's instantaneous because I guess it was already on disk. And if we look at the console, well, there's even nothing to see. I mean, it just installed Emacs in my just install Xyle in my profile. Yeah, I can see here it's been installed. Right. Anyway. And so, you know, this web interface it's really cool because it's a small piece of software, but it's made possible because everything is a library and because all the distro, all the packages can be manipulated so easily. Yes, so that's the thing. What else? I'm lost. Okay, so we've seen a bit of what's hackable with Guix. So far we were pretty much on the tool side. So here we have the tool side, which means, you know, the Guix package commands and also libraries, which allow you to traverse the list of package definitions. But then there's also the build side. So what happens when you build a package with Guix is actually the Guix program, so Guix package, for instance, just talks to the build daemon. So the build daemon, if you were at Nicholas' talk this morning, it's the same as the Nix daemon. So it's a C++ daemon, basically, which takes care of setting up CH roots, containers, roughly, with, you know, separate namespaces, separate UIDs, and everything. So when you're actually building software on your machine, you're just talking to that daemon, and the daemon itself creates those containers. Right. And inside those containers, we also use Guile, so the scheme implementation, to write, you know, all these scripts to actually build packages. So that's pretty cool. Let me give you an example. So again, if I go back to the REPL, so I can say enter store monad, which means I'm going to do stuff which modify this GNU store directory. And I can say, let's compile this Emacs package definition. So let's turn it into a derivation. Derivation is a low-level representation of the package build actions. And I'm getting those, again, those weird file names. It doesn't seem so weird because there are ellipses to hide the hash, which we can turn off. Yeah, normally it looks like this, but again, there's an Emacs mode to just hide those long hashes. Yeah, and I can say, okay, let's build it. Let's build this derivation. And okay, it's already on disk, so it's instantaneous because it's in cache, basically. And if I go to that directory, well, I have Emacs right in there. So this is a pretty much high-level view of what we can do with packages, but we can also operate with scheme expressions at a lower level. So we can send very basic scheme expressions to the daemon and ask it to build it. So for instance, I can send it a G expression, which is an expression representing build actions. I can say foo, and I enter the actual build expression. I don't know whether. Hello. And make the output directory. Right. And again, I get one of these derivations. So I can also copy-paste that file name and pass it to one of the command line tools. So if I do Guix build of that drv thing, yep, then it just, yeah, we see that hello thing. And it just built the thing, so it built an empty directory, basically, which is, okay, not very useful. But you get the idea. We're using scheme in different places, which means we're able to reuse code, and we have libraries also to handle all the build actions and stuff required to build packages. Okay, so far I was talking about packages themselves, but again, we can go a bit further, and we actually have a similar approach to operating system configuration. So what does it look like? So, well, again, the thing is, if you want to install an operating system or if you want to modify its configuration, you just write a declaration of what you want your operating system to look like. So you give, a bunch of usual details like the host name, time zone, bootloader configuration, file systems, that sort of thing, user accounts, services, and globally visible packages. And guess what? It's again scheme code. So if we try to inspect all these names of these variable names, we see, it's just a regular scheme variable. So again, if I want to see what's in base file systems, which is the basic set of file systems which are going to be mounted, I can just jump to the definition and I see, yeah, it's okay. We have 3 file systems which are mounted by default. That's fine. Here we have services. So services are things which are going to run, when you start the system. We have the Slim service. So, Slim is one of these old login manager for X11. It's not really fashionable. I guess we'll probably have GDM or something like that later. But so far, that's what we have. So, yeah, again, I can jump to the definition. And I can look at how it's actually written. So Slim service is just a regular scheme function which takes a number of parameters. And yeah, there's a lot of documentation. And basically, it returns a service. Yeah, unsurprisingly. And the service just gives an expression which says how we want to start the service. And later on, it gives an expression which says how we want to stop the service. So what action must be taken when the service is stopped? We see this hash tilde thing, which means it's an expression that is going to run at runtime when we actually start or stop the service. Yeah, we have a bunch of other services. So what we can do with this declaration, well, we have a tool which takes an operating system declaration as an input and can do a number of things. So it's a Guix system command. If you run Guix system build, and that file was called GNU system. Where am I? Yes. So I can run the Guix system build command and pass it this file which contains this declaration I just showed. And if everything goes well, yeah. It's building a number of things, like it's currently building the initial RAM disk, I think. And here we are. So we end up with, again, a directory. And if I jump into the directory, well, I basically have all the closure of what's needed for this operating system. So similar to what Nicholas showed this morning, we have a single directory containing everything, all the configuration of the operating system. So we have a baud script, the etc directory, the initial RAM disk, the kernel, and a number of other things. So far, so good. So I can also ask it to build a virtual machine. Yeah, with that kick system VM command. It's a bit slow. I don't know if it's trying to access the network. Yep. Okay, it's populating the virtual machine image. And here we are. We get a script that we can run to actually start the virtual machine which contains the operating system we configured. So what happens when we run it? Well, it boots. Wonderful. it creates a number of user accounts at the beginning because it's a fresh disk image, so it doesn't have any user account at the beginning. And yeah, if I jump to, so I can jump to the TTY, and I don't know if you can read it. It's a bit, yeah, dull. Well, we get to TTY, and we can log in, and we have everything we wanted to have, right? And I can also go to the login screen. So this is a slim login manager, and I can log in. And yeah, I'm getting a window maker session. Again, not something very fancy, but we also have XFCE nowadays. I haven't tried it yet, so. External. And this is it. So we can, from there, we can actually run we can query the init system. How can I do? Crap, I don't know what happened. I just go back to my own machine. So we're using a quite original init system, which is GNU DMD. So I guess most of you haven't heard about it. It's not new actually. It's quite old, but we just revived it for the purposes of Guix. So to talk to the init system, to PID1, we use the deco command, and I'm doing it on my laptop here. And so if if I run as root deco status DMD, then I can list all the services which are started or stopped on my system. So, well, we see many services listed here. So we have, for instance, this service just takes care of enabling crypt setup for my home directory. Then we have services which set up the font on TTY1 to TTY6. We have services for each file system to be mounted at startup time. And we have services for normal daemons like the Guix daemon itself, and I guess, yeah, Xorg, stuff like that. And so we can stop and start services like, I can stop the name service cache daemon with this command and restart it. You get the idea, right? And so, if we summarize what we have here, we have the kernel. And from there, we have an initial RAM disk. And actually, it turns out we run Guile in the initial RAM disk. So we can use all our friendly Guile libraries within the RAM disk. And from there, we have PID1, which is DMD. And again, that's Guile. So again, we can reuse our friendly libraries, scheme libraries, within that daemon, right? And then we have userland, so with everything you want. So the cool thing is, yeah, we're able to reuse a bunch of code here. And if you look at things like, something like device mapping, you want to be able to do them both in the init-rd or at system initialization time from PID1. And so it's very useful to be able to reuse this kind of code. And building an init-rd is something very simple. We can do, expression to init-rd. And let's say I want to, I want to display something. And then, I don't know. So let's say I want to start Emacs from the init-rd itself. I can say something like that, right? And I can just build that init-rd, and it will automatically create an init-rd with Emacs and all its dependency within the init-rd. And the init-rd will display hello and then start Emacs. Wonderful. We're running out of time, I guess, so I won't try it now. Okay, so what's the status of the project? So just to summarize, it's a pretty young project. So it started off Nix. I've been working on Nixos for 4 years before, and started working on Guix 2 years ago, roughly. And so it entered the GNU project in 2012, and then we had a number of milestones. So the first time we had an actual installable operating system was recently this summer, and then we keep adding more features. And so the last release was actually 2 days ago, and yeah, another fabulous hacker ported Guix to ARMv7. So we now have an ARMv7 port, and lots of bugs fixes and stuff. And 1 day ago, Guix was officially recognized by the FSF as FSDG compliant, so compliant with the Free Software Definition Guidelines, which is cool. Our status. So this is great and everything, but yeah, this is dog food, right? So you know what I mean. So what's the status? So we have a full-featured package manager. We have 1,000 packages roughly, which is, I think, 20 times less than Debian. Okay. It supports 4 platforms, so basically Intel and MIPS and ARM. And we have that Guix system distribution, which is a standalone operating system distro. And this is the part which is kind of still dog foody right now. It's really improved with the last release, I think. I hope so. Well, I'm using it daily, and it works quite well for what I'm doing. But we don't have things like, we don't have GNOME, KDE. So if that's your thing, you might be disappointed. And we like a few things like Network Manager or Wikid or something like that, which makes it, not so convenient sometimes. We serve binaries. We have a lot of tooling because since we can easily manipulate, packages, we have a lot of tools to, for instance, automatically update recipes or to lint recipes, so which is to say to flag problems in recipes. And we have internationalization of all the software and the package descriptions. Yeah, it's quite active. There are commits. There are quite a bunch of people. So it's saying 36 contributors last year, which is cool. But yeah, it's a lot less than Debian, of course. We're working on it. Yeah. So thanks. I would like to thank everyone who contributed to Guix because. They are brave people and really awesome hackers. So thanks to them and thanks to my employer also for allowing me to travel to Brussels. Work in progress. So we have people working on those big packages, big scary packages. So actually we got ICE very recently, and people are working on LibreOffice, KDE, and stuff like that. It's a bit scary to me, but I'm glad that people are actually working on it. We have someone who started a GNU herd port because, the GNU system is supposed to use the herd. It's work in progress. There's still a lot to be done. We have someone, so David Thompson developed GixWeb, which is this web interface which I showed you. And another thing is Guix Publish, which will allow normal users to publish their binaries over HTTP, so we can build some sort of a peer-to-peer network. The road to 1.0, well, we need more OS features, we need more services, as I said. Yeah, we have a Guix system reconfigure command, which allows you to modify your system configuration, but it's a bit static currently. Would like it to be more dynamic, like being able to restart a number of services and everything. Yeah, lots of things to do. We need a better build farm. We have problems sometimes because it's a small build farm. Yeah, less dog food, more packages, and yeah, if you have ideas, we'd like to hear from them. So you can help by installing the distro, reporting bugs, sharing ideas, and there's a friendly community on IRC if you go to #Guix on Freenode. So I invite you to join us. Thank you. I don't know if we have time for questions. Is time?
You've got like 30 seconds.
30 seconds for a question, maybe one question. Yes.
Can you explain what the differences with Nix? It seems very similar.
So what are the differences with Nix? So basically we're reusing, I mean, Nix and Guix are both functional package managers. So you get the same kind of features from a user viewpoint. And we're actually reusing the low-level stuff of Nix, which is the Nix daemon, the thing which set up, containers. But then the rest is completely, it's a separate code base. And so we have this scheme stuff, which is, I think, more hackable than what's available in Nix. So in Nix, you have a specific language to describe packages, and then you have another language in which the rest is implemented. You have C++, you have Perl and stuff. So it's a different approach. And also, we're using in the system, we're using DMD, and it's a different. They're using system difference, and so it's a different approach. Yeah.
So what other thing you mentioned, environment modules?
Yes.
At the beginning of your talk. I'm a system administrator at the supercomputer side.
Yes. Yeah. 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 Sure. So you're arguing that environment modules are more convenient on clusters, right? Environment modules are more convenient for clusters, is what you're saying, right? Yeah. Yeah. Okay. Well, my experience at INRIA suggests that it's still quite limited, but yeah. Yes, sure.